Welcome to the deep dive. Today, we're plunging into a really intriguing concept, sleep time compute.
Right.
You've flagged some fascinating material for us. There's this paper, Sleep Time Compute, Beyond Inference Scaling at Test Time. Then a great explainer video from Matthew Berman's channel breaking it down.
Yeah, that video is really helpful for visualizing it.
Totally. And the full research paper PDF, too, for, the nitty-gritty.
Mm,
So our mission today is basically to unpack what this sleep time compute idea is really all about, why it matters, and maybe what surprising things it could mean for AI going forward.
it's definitely a timely topic, and the sources give us a good range, right? We've
Mm.
got the core research paper introducing the concept.
The foundation.
Exactly. Then the video, which makes the mechanics and benefits a bit more accessible.
Yeah.
And the full paper for all the experimental details and the finer points should give us a solid grasp.
Yeah, it mentions that phrase inference scaling at test time in the intro. What's that about again?
Oh, right. That basically just means, trying to get better AI results by throwing more computer power at the problem when you actually ask the question at test time.
Okay.
And this paper is looking at ways to go beyond just doing that.
Gotcha. Okay, so let's get down to it. What is sleep time compute at its heart? What's the fundamental idea?
Well, at its core, sleep time compute is really about changing when an AI model does its thinking or its processing specifically related to the information you give it.
Okay.
So instead of waiting until you ask a specific question, the model actually proactively works on understanding the context before your query even shows up.
Huh. Okay, so it's like giving the AI a head start. I liked that analogy you sent over.
The study buddy one.
Yeah, imagine giving a really complex research paper to a super smart study buddy the night before a big quiz.
Right.
They can read it, digest it, connect the dots between sections, maybe even start thinking about what questions you might ask.
Exactly. They're anticipating.
That pre-reading and sort of understanding, that's basically what sleep time compute is trying to do with AI.
That's a really good way to put it. Your study buddy isn't just like storing the words passively. They're actively processing the information, building a mental map. Sleep time compute lets the AI do something similar with the data you feed it.
Okay, this already sounds pretty clever, but what's the actual problem it's trying to solve? The paper and the video, they both mention limitations with how AI works now.
Yeah, the main issue is with what they call test time compute.
Yeah.
So right now, when you ask an AI something, say, about a document or some code,
Mm-hmm.
the model usually processes your question and the relevant background info, like more or less at the same time.
Okay.
And Matthew Berman points this out in the video. Making the AI do more work at test time generally gets you better answers, but it comes with real downsides.
Right, I remember the video hitting that hard, it can get really slow.
Super slow sometimes.
And expensive too, right? Like seconds, maybe even minutes for a response. And all that GPU power adds up, costly. Tens of dollars per query, potentially.
Exactly. It can get pricey. And a big reason for that inefficiency, as both sources explain, is that the old way often treats every single question like it's starting fresh, from zero.
Even if you're asking about the same thing.
Yeah. Even if you ask 5 questions in a row about the same document or the same bit of code, the model has to sort of reprocess a lot of the same underlying context every single time.
Wow.
It's like your study buddy having to reread the entire paper from the beginning before answering each question, even if the questions are related.
That just sounds incredibly inefficient, especially when you think about how many AI tools are actually meant to handle ongoing stuff, like state or context that sticks around.
Right, like coding assistants. They need to know the whole project.
Exactly. Or chatbots remembering the conversation, or even just asking multiple things about one research paper. It feels like the AI should be able to, hang on to what it learned and build on it, not start over every single time.
Precisely. And the researchers point this out. Many real-world AI applications inherently deal with this persistent context. It just seems wasteful for the AI to have to keep reanalyzing the same background info again and again.
Okay.
And that's really where this idea of sleep time compute comes in and, well, potentially shines.
All right, so let's dig into how it actually works then. What's happening during this offline processing phase? What's the magic?
Okay, so the process kicks off when you give the AI what the researchers call raw context.
Raw context, like the document, the code.
Exactly. It could be a document, code, conversation history, any data that's relevant to what you'll be doing later.
Yeah.
That's step 1, the foundation.
Got it. Feed the AI the info. Then what? Does it just nap?
Not exactly nap, but it uses its idle time, that's the sleep time, to pre-process this raw context. That's the crucial bit. During this offline processing, the AI is actively working. It's identifying connections, uh, relationships within the data, trying to understand how different parts fit together. And importantly, it also tries to anticipate the kinds of questions or tasks you might ask later based on that context.
Whoa. Okay, so it's not just reading passively. It's actively trying to understand and predict. The paper mentioned it generates a, what was it, new context consisting of inferences about the existing context. That sounds a bit dense.
Yeah, it does sound technical. But think back to the study buddy again.
Okay.
After reading the paper, they might jot down summary notes, right? Or highlight key arguments, maybe even make up potential quiz questions and answers.
Ah, okay. Their own notes.
Exactly. This new context the AI generates during sleep time is kind of like that. It's a different version of the original data, but it's enriched with the model's own understanding, the connections it found, its guesses about what might be important later. It's like the AI is building its own internal cliff notes or knowledge graph of the information.
That makes a lot more sense. So the AI does all this prep work. Then I finally show up with my actual questions. How does it use this pre-cooked context?
So when you do ask your question, the AI doesn't just look at the question by itself. It combines your query with this pre-processed sleep time context it already built.
Hmm.
And because it's already done some of that foundational understanding, that reasoning offline,
Mm.
it can often spit out an answer much faster and potentially using less compute power right then and there. Some of the heavy lifting, the cognitive work is already done.
Right. Like my study buddy having their notes ready, they don't need to flip back through the whole chapter. And crucially, the paper says you don't need like a special command to make this happen.
Sure.
It just kicks in when you provide the initial context.
Exactly. Just
Yeah.
giving it the relevant context is the trigger. It sets the stage for the system to do its sleep time thing. Makes it pretty seamless for the user, actually.
Okay, yeah, I can see why this could be huge for speed and cost. That video, Berman's video, really drove home how test time compute can mean delays and big bills. Sleep time compute sounds like a really smart way to dodge some of that by shifting the work to maybe cheaper idle times. Use that great juggler analogy. Counting tennis balls. Can you remind me?
Sure. It illustrates the redundancy of just using test time compute.
Yeah.
So imagine the raw context is a description like a juggler juggles 800 balls, a quarter of tennis balls, and so on.
Okay.
With standard test time compute, if you ask how many tennis balls, the AI has to process that whole description every time.
Every single time.
Yeah, even if you asked something similar before, it's like
Yeah.
it has to recalculate that a quarter of 800 is 200 each time you ask.
Right. Constantly redoing basic math.
Exactly. But with sleep time compute, the idea is the AI processes the context beforehand, figures out, okay, 200 tennis balls during its sleep time.
Okay.
So later, when you ask how many tennis balls, it can just pull up that already calculated fact almost instantly. It shifts the main computation to when resources might be less busy, less expensive.
That learned context idea seems really key then. It's not just storing raw data, it's actually developing an understanding through the pre-processing.
Precisely. That sleep time work lets the AI build this richer, learned context, which then lets it answer questions later much more efficiently. It's moved beyond just having the raw facts to actually having derived insights from them.
And this gets really powerful when you ask lots of questions about the same stuff, right? The research talked about cost amortization.
Yes, that's a huge benefit they highlight. The cost of doing that initial sleep time processing can be spread out or amortized across all the related questions you ask about that same chunk of information.
So the more you ask.
The more you save, essentially. If you upload a big research paper and ask 10 questions about its methods, findings, conclusions, that initial sleep time compute effort pays off more and more with each query.
Compared to processing the whole paper from scratch 10 times.
Exactly. Big savings compared to that. They even made a specific data set, the multi-query GSM Symbolic, just to measure this effect properly.
And what did they find? Did it actually save much?
Oh yeah. Their experiments on that data set showed that using sleep time compute across multiple related questions could cut the average compute cost per query by about 2.5 times.
Wow. 2.5x.
Yeah, which, I mean, if you think about companies running AI at scale, that could mean millions in savings on compute costs every year. It could also, make powerful AI more accessible for smaller teams or individuals who can't afford massive GPU bills.
That's potentially huge. Okay, but what about accuracy? You shift the work around, maybe do less work at test time. Does that mean the answers aren't as good?
Well, this is where it gets really interesting. The research found that in many cases, sleep time compute could actually match or even beat the accuracy of standard test time compute.
Beat it. Really?
Yeah, and it could do that while using way fewer resources, sometimes up to 5 times less compute on their tests.
5 times less compute, same or better accuracy.
Exactly. And what's more, they found that if they gave the AI more thinking time, during the sleep phase basically, scaling up the sleep time compute, they could boost accuracy even further. They got gains of like 13% and 18% on a couple of their key benchmarks.
Wow.
Think about fields like, I don't know, medical diagnosis or legal research, where even small accuracy bumps matter a lot. So it's not just about saving money or time. It can genuinely lead to better results.
Okay, that's a really powerful combo. Cheaper, faster, and potentially more accurate. That's compelling. The paper also compared it to something called parallel sampling. What's that, and how did sleep time compute fare against it?
Right, parallel sampling. This is another trick people use to try and get better AI answers. Basically, you ask the model the same question multiple times, get several different responses back,
Okay.
and then you try to pick the best one out of the bunch. It also uses up compute resources, obviously, processing all those potential answers.
Makes sense. But how do you know which one is best?
That's the tricky part, as Berman mentioned in the video too. Choosing the best answer reliably is hard. But the researchers found that sleep time compute consistently did better than parallel sampling when they were given the same budget of test time compute resources, the same number of tokens processed at test time.
Consistently better, across the board.
Yeah, across all the tasks and models they tested. It suggests that fundamentally, it's better to proactively build a stronger internal understanding of the information first, like sleep time compute does, rather than just generating a bunch of answers at the end and hoping you pick the right one.
Okay, so it seems like a more, maybe, reliable way to boost performance than just asking for lots of options. Now, the research also looked into when this whole sleep time approach works best. What determines its success?
Yeah, this was a crucial finding. Its effectiveness is really strongly tied to how predictable the follow-up questions are, based on that initial context you provided.
Predictable. How so?
Well, back to the juggler example. If you give the AI a super detailed description of the juggling act, types of balls, colors, numbers, right, then questions like, how many indigo tennis balls are there, are pretty predictable, right? The AI can kind of anticipate you might ask about specific combinations during its pre-processing.
Okay. Yeah, it can focus its sleep thinking on the stuff that's likely to come up.
Exactly. But if, after all that juggling prep, you suddenly ask the AI, what's the weather like in Timbuktu?
Ah, right.
Well, the sleep time processing about balls isn't going to help much, is it? Because the question is totally unrelated and unpredictable from the context.
Gotcha.
The researchers actually tried to measure this question predictability and found a really strong positive link. The more predictable the questions, the better sleep time compute performed.
So the closer the follow-up questions stick to the original topic, the bigger the win for sleep time compute. Makes sense. And for really complex or totally out-of-the-blue questions, maybe just sticking with regular test time compute is still the way to go.
That seems to be the key nuance, yeah. It's not a magic bullet for everything.
Right.
Its real strength is in those scenarios where there's a reasonable expectation of what the user might ask next about a specific context.
They also tested this in a more real-world setting, right? Software engineering, using that SWE features benchmark. How did it do there?
They did. They applied it to a task that involved figuring out which code files needed changing to implement a new software feature. A pretty realistic task.
Yeah, definitely.
And they found that when the test time compute budget was kind of low or moderate, sleep time compute did help. It improved performance in predicting the right files to modify.
So it helped the AI get started.
Kind of, yeah. The idea is the AI could explore the code base beforehand, during sleep time, get a better feel for the project structure, the potential impact areas, before tackling the specific feature request, like getting the lay of the land first.
It makes sense for coding, but there's a but coming, isn't there?
Huh. Well, sort of. They also noticed that if you gave the AI a massive amount of test time compute, like virtually unlimited resources right when the question was asked,
Okay.
then sometimes the standard test time approach actually did a bit better on this specific task. Their guess was that with unlimited power at test time, the model could just laser focus on the specific query without needing that broader pre-processed understanding.
Interesting. So it highlights that the balance between sleep time and test time might be important depending on the task and how much compute you have available right now.
Exactly. Sleep time showed promise there, but maybe the benefits have limits if you can just throw infinite resources at the problem at the last second. It's about finding that sweet spot.
Okay. So thinking about limitations then and where this research might go next, what did they point out?
Well, the big one we've discussed is that dependence on question predictability. That's key. Also, the current model mostly assumes this clean split, right? There's sleep time processing, then later there's test time querying, but real interactions are often messier, back and forth, context changing.
Yeah, more fluid.
Exactly. So the researchers suggest future work could look at dynamically shifting compute between sleep time and test time, maybe based on how predictable the next question seems, or how much the context has changed.
Smarter allocation.
Precisely. And they also see potential links to other big AI areas, like representation, learning how AI understands and encodes info. Maybe sleep time preprocessing helps AI learn better, more efficient internal representations of data.
Ah, interesting.
And also maybe synthetic data generation. If an AI deeply understands a data set from its sleep time processing, maybe it could generate more realistic fake data based on it. Lots of interesting avenues.
This definitely sounds like a promising area with room to grow and get refined. Okay, so let's bring it home. For you, the listener, tuning in, what's the main thing to take away from this deep dive into sleep time compute?
I think the fundamental takeaway is that sleep time compute offers this really um, innovative way to make our interactions with AI potentially faster, cheaper, and maybe even more accurate.
Yeah.
By letting the AI models proactively chew on information beforehand, we can move past that simple request-response loop and unlock some serious efficiencies, especially if you're dealing with lots of information or asking follow-up questions. It could genuinely change how you experience AI tools down the road.
And for me, the real aha moment is just that idea of AI thinking ahead, preparing before we even ask. It feels like a different way of thinking about AI, not just a passive tool waiting for input, but something actively getting ready to help. It mirrors how we work, right?
Right.
Anticipating things.
Exactly. That proactiveness is key. And look, as AI gets woven more and more into everything we do, making it efficient and cost-effective is going to be absolutely crucial. Sleep time compute tackles those challenges head on.
Definitely. So finally, maybe some food for thought for you listening. Think about the kinds of information you work with regularly. Documents, code, meeting notes, whatever it is. Could this idea of AI pre-processing that stuff actually lead to smarter, faster help for you?
Yeah, what are the implications for the tools you use every day? Does it matter more for real-time stuff or for tasks you do more asynchronously?
Lots to think about. This research really opens up a fascinating new angle on how we can interact with and really leverage AI power. Thanks for joining us on this deep dive.